All right, so I'm going to show you HY8. We did this example in class. I'm going to go over this example and then I'll show you a more detailed example. So it says create a new project and we're going to add a culvert crossing. So I'm just going to go ahead and leave that as is. I'm not going to use the feature map to locate. I'm just doing this basic. So I'm going to go continue. Now, this is the data that we have to fill in. We have to fill in a minimum, a maximum, and a design. So let me cancel that for just a second so I can pull this over so you can see it. So I can go culvert, new culvert crossing, same tables brought up. So minimum flow I'm going to leave is 0, 65 is the CFS, and I'm just going to type in 100. It doesn't matter. You have to have 3 of them though. So we don't know anything about the tailwater because it's saying that headwater is being controlled. The problem actually gave us the example that the headwater was. So I'm going to pretend that it's a trapezoidal channel with a bottom width. And here's the thing, it says it's a 36 diameter pipe. So I'm going to say the bottom width is 3 feet with 4:1 slopes. And the Manning's N is going to be 0.015. Let's say it's a concrete line channel. The invert, I can make it up and I can leave it as 0 if I wish. I can do 10, 20 because this isn't a specific elevation, but it does say, thus the invert over here is 450. So I can say 450. Now, the roadway width, again, this is not given in the data, but you do have to put something in. So, well, let me try and leave it as 0 here. So one concrete is going to be, notice that this is circular concrete. These are the shapes. The diameter is going to be 3, oops, wrong one. The diameter is going to be 3 feet. 36 inches, so 3 feet. There's no embedded depth, concrete, straight, square edge with head wall. This one says the culvert has a head wall with a grooved edge, so I need to change that to a grooved end head wall. There's no depression. Inlet station, I'm going to leave this as is, and I want to show you what the defaults say. When I click on Analyze Cross-Section, it says I have to have data for the roadway. So our first station 0, we're going to just say that the road is 100 feet wide, and the elevation, if the headwater is, or if the invert is at 45 or 450, I'm going to say at least plus 3 feet. I'm going to say 455. 455. I get 455 because if the entrance is at 450 and it's a 3-foot diameter pipe, that would be 453, and then 2 more feet of cover, and then I'm set. Now, site data, we can put the inlet outlet elevations. We can say the inlet elevation is 450. The outlet station is maybe 50 feet wide, so that's the top of the road, so the outlet would be 449. Let's say that's the cross slope. And then I can analyze it, and it says the roadway width, my bad. Roadway width here. The first station is going to be, oops, I'm sorry, I need to pull that down. There's the roadway width. We're going to say that's also 50, okay? Analyze cross-section. Now, when I analyze the cross-section, here's what the cross-section looks like. I can click on the data. I can look at the information here. So, culvert processing data. So, I clicked on that too quickly. That's what I'm looking for. So you can see that the headwater at the 65 is 454.63, and this one's 454.71. So it is really close to the elevation that we anticipate this to be. You can also see that the cross section is drawn on here, and you can see the water surface profile here and the tailwater or the cross section down here. Okay, so I just wanted to show you a quick demonstration of the examples that we did in class. Here's another one. So I'm going to go at a culvert crossing. This is crossing 2. And now this one's got 80 CFS, so we'll do 80 here. Maximum flow again is 100. It is a box culvert, 3 foot by 6 foot. So the bottom width is going to be, we're going to say the box culvert goes into a box channel. The slope is going to be the same. Does it give me the slope up here? No. So I'm just going to put a channel slope in of 0.0, we'll say 1%. Now, from there, we have a Manning's N of 0.015. The channel invert is 450 again. So 0, we'll say 100, 455, 50. Now this time it's not circular, it's a concrete box. The material is concrete, the span is 6 and the rise is 3. There's no embedded depth, it's straight. It is a wing wall with 45 degrees. So there's a square edged wing wall, 45 degrees. Input, station start, inlet elevation 450. Outlet, I'm going to say 449. I'm sorry, not station. Outlet station's 50, 449, and there's only one barrel. Analyze the cross section, and what it gives me is 2.73 feet. So at elevation, or at a total discharge Q 80 CFS, my headwater is 452.71, and the headwater was 452.73. So you can see the HY8 program works really well with matching the charts. Now, I'm going to do an example in the next video that goes over all the different points of all the different applications of an example problem.